Okay, objective 152 is students will be able to understand and apply the power of a power rule. Okay, let me change that. Understand and apply the power of a power rule. Okay. Want you to, in a second, hit pause and then match these. Let's see, match these right here. There are 5 things, the 5 numbers here with the examples on the right. So, for example, number 1, the product of powers. Okay, which one over here shows the product of powers? And you're going to write that letter choice right there. And then you're going to find out quotient of powers. Which one over here shows that? Okay, so you're going to write all of those letter choices in. Now, the last one, power of a power, you have not learned. But you can use process of elimination to help you find that answer. So go ahead and hit pause now. Then when you're done, unpause it. We'll see if we got the same thing. Okay, so the product of powers, let's see, when you multiply, what do you do with the exponents? Well, you add them. Which one shows that? This one down here. So number 1 matches with E. Quotient of powers, when you divide, what do you do with the exponents? Should know that you subtract. Which one shows that? This one down here, D. Okay. The 0 exponent, anything, if it's all raised to the 0 power, we know that anything to the 0 power other than 0, okay, other than 0, because 0 to the 0 power, okay, do that on your calculator. Okay, 0 raised to the 0 power, okay, it's an error, okay, so you can't raise 0 to a 0 power, but if it's anything else, we know that the answer is going to be 1, so we know that it's C. Negative exponents, well, what do we do with the negative exponent? Okay, we use the reciprocal of the base, okay, and then that will make it positive. So which one shows that? This right here, that's B. The last rule that we're going to learn about is called the power of a power. Okay, it's really important that you think about the name and what that actually means. Okay, the power of a power. If you look at this, okay, you have a power, and guess what? This entire thing that had the power is raised to what? Another power. Power of a power. That's where they got it from. Okay, and that was letter choice A. Now, let's look at a letter choice A. Okay, right here we see, and this is the key rule for today, okay, that what we do with these powers, or the exponents, is that we multiply them, and we keep the same base. Okay, so this property right here illustrates what we're going to be doing today. Okay, so let's move on to these down below. As you've learned in some of the previous objectives, there are several different ways of showing our work for some of these things. So, for example, if we look at these 2 problems, okay, we can do these one of 2 methods. Okay, the first method, let's just apply the product of powers. Okay, so we're going to apply the product of powers. Okay, that'll be the first one that we're going to apply. So, what do we do when we're multiplying? Well, we showed it here. We add the exponents. Okay, so negative 4 plus 4 would be 2 to the 0 power. And you notice the bases of 2 did not change. The base does not change. Okay, 2 to the 0 power we know is just 1. Okay, so this property right here is just the 0 exponent property. Okay. Now, the other method that we could use for this, instead of just multiplying right away and adding our exponents, we could use the negative exponent property. So the negative exponent property. Okay? And all that says is if you have a negative exponent, we're going to take a reciprocal of the base. So this right here was 2 to the negative 4. It was on top because, again, we can write anything as a fraction over 1. So what did we do with that to the negative 4? Well, we moved it to the denominator and made it positive. Okay, and then you still have times this 2 to the 4th power. Okay, when you do that, you end up with, because this would be over 1, you end up with 2 to the 4th in the numerator over 2 to the 4th in the denominator. Okay, and what do you do with the exponents when you are dividing? Remember, this base of 2, because it's a base and not a coefficient, does not change. When we're dividing, we subtract the exponents. So it would be 2 to the 0 power. Again, anything raised to the 0 power is 1. Okay. Again, just wanted to remind you on the 2 different ways that we can show things. Okay. Alrighty, let's go over the power of a power rule. Okay, when raising a power to another power, we need to, what do we need to do with the exponents? Well, we saw on the last page, we need to, and you guys should have a lot more room than me, I'm going to write it down here. We need to multiply, multiply the exponents. Okay? So let's look at this first one. First of all, it's really important to understand what we're actually doing when we're working with exponents. Remember, and you guys need to write this above here, if I give you 2 to the 5th power, that's the same thing as saying 2 times 2 times 2 times 2 times 2. You take this base and you multiply it by itself however many times the exponent tells you. Okay? We're going to do the same thing with this one. What's the base? Well, the base is w to the 2nd power. Okay? How many times do we need to multiply that by itself? Well, 5 times, because that's the exponent. Okay? Again, I'm going to prove to you where the rule comes from. So w to the 2nd, and finally w to the 2nd. Okay? Now, when you're multiplying, what do you do with the exponents? Well, we ought to know this by now. You add them. So the long way of showing it would be 2 to the, let's see, 2nd. 2 plus 2 plus 2 plus 2 plus 2. Is that 5? Okay, which would equal w to the 10th power. Okay. Now, there is a better way of doing it. Okay, and that is this. We can apply this power of a power rule. Okay, all this rule is, you guys, all it is a smart cut. Instead of having to write this out every single time where you multiply that base times itself and then add the exponents, okay, the smart cut is we know, if we look at this, how do we get to 10? Well, we can do, let me zoom in here, we can simply do 5 and distribute. Okay, basically just show that line of distribution. And then the work for it would look like this. It would be w to the 2 times 5, which is equal to w to the 10th power. So guess what? The smart cut, again, we just proved that the smart cut works. They're the same. Okay, let's apply that for this next problem. And I think your guys' problem is down a little bit further, but that's fine. Okay, now if we did this the long way, and again, I want you guys to show that you can do this the long way too. This would be x to the 3rd over 5 times itself. How many times? Well, 2 times. Okay. Now, again, how do you multiply fractions? You multiply across. So x to the 3rd times x to the 3rd. When I'm multiplying, I know that I add the exponent, so that'd be x to the 6. And then 5 times 5 would be 25. Okay? So that's if we do it the long way. But we can use our smart cut now. Okay? Now, before we get into the smart cut, okay, I'm going to again, and Miss Stegeline do this a lot, we're going to tell you the most common mistakes. Okay? We're going to tell you the most common mistakes. So, here's what they are. And the most common mistake on this one all stems from not doing one thing. Okay? When you don't have exponents shown, what should you do? Okay? You ought to know this. okay, you need to put the hidden 1 on every exponent that's not shown. Okay, so I'm just going to tell you right now what the common mistake is. So key point, and it's a common mistake. So you guys are just writing this right below it. Again, yours is in a little bit different position. Common mistake. To forget hidden 1s. Okay, that will destroy you, especially on this objective. Okay, so when we do that, okay, and let me zoom in a little bit. Okay, when we do this, we need to distribute this 2 times the 3, and we need to distribute it times this. That power on the outside, you need to distribute to every single exponent and power, including the hidden 1s on the inside. Okay, so I'm going to come down here. You guys should have a little bit more room underneath yours. Okay, what this would look like, and again, this is work that you need to show. X to the, okay, when you distribute, remember we're multiplying. X to the 3 times 2 over 5 to the 1 times 2. Okay. Again, when you distribute, you're just multiplying. So that would equal x to the 3 times 2 is 6, and then 5 to the 2nd power. Okay, which simplifies to x to the 6th. 5 to the 2nd power is 25. Guess what? Our smart cut way, okay, got us the exact same answer. Again, that's where this rule comes from. Okay, we didn't just make it up. It's a rule by finding patterns. So let's fill in our table here. So get this a little bit straighter so you don't go dizzy. All right, so in numbers, if you have something like this, in parentheses you have 3, and then a squared, all raised to the 3rd power. Okay. Now, remember, I already told you what the most common mistake is. Okay, and let's do it over here so that you can cross it out. Here's the most common mistake. You would do 3 to the a to the 6th power. Gotta tell you right now, this answer will show up on quizzes because you guys aren't listening carefully, or you just forget. And I'm telling you what the mistake's going to be. So let's not make it. Take about 10 seconds. See if you can figure out what mistake I made. Okay, hopefully you discovered it. What are all the exponents on my numbers or variables on the inside? Well, 3. If there's not an exponent there, what is actually hidden there? And you should know that there is a hidden 1. Okay, so again, you can draw an arrow from your key point to right up here. Okay, so then you got to distribute and you got to distribute. Okay, which turns into 3 to the, so cross that thing out, okay, and just put a note, forgot hidden 1, okay, so this would be 3 to the 1 times 3, okay, and this would be a to the 2 times 3, okay, hopefully your 3's look a lot neater than mine, okay, so then this would be 3 to the, 3 to the 3rd power, and then a to the 6th power. Are we done? No, because you can do 3 to the 3rd power. 3 times 3, 9. 9 times 3, 27. So the final answer for this would be 27a to the 6th power. Okay. In algebra, we already kind of saw this. If we say in parentheses x to the a power, okay, and then raised to the b power, we simply show this as x to the a times b. Okay, again, power to a power, 2 exponents. Okay, an exponent on another exponent, we distribute and multiply those. All right, so let's do a few examples. Okay, and now keep in mind what the most common mistake is so that we can avoid it. Okay, so let's zoom in on this guy. What do we got to do on this one? What's the first thing that you should look for? sure that you don't do that. So this 2, again, any number. If I just write the number 8, okay, what's the exponent on 8? There's a hidden 1. So what's the exponent on 2? Hidden 1. Distribute. Because you have a power outside, okay, raising everything else to another power. Okay, so when you do that, you end up with this. Now, keep the numbers in parentheses. So you have 2, okay, 4 times 1, okay, 4 times 1 is 4. And then x to the 4 times 4 is 16. Okay, are we done? The answer is no, because 2 to the 4th power is going to give you 16. So you'd have 16x to the 16th power. That is your simplified answer. Okay. Again, and this is probably the last time we'll do the proof. Here's the proof behind it. Okay. We would take this whole thing in parentheses, 2x to the 4th, and multiply it by itself how many times? 4 times, because that's the exponent on the outside. So write this out with me. One more, 2x to the 4th. Okay. If you just had this, you're multiplying a whole bunch of terms. What do? Multiply the coefficients, add the exponents. So this would be 16 x to the 4 plus 4 plus 4 plus 4. Man, I love smart cuts much more. 16 x to the, when you add all those up, you still get the 16th power. Same thing. Okay. Let's move on to the next example. Okay. This one, again, it is so important that you put in those hidden ones, especially with, okay, a power to a power, because again, here's what's going to happen. Okay, watch. Boom. Boom. What about this guy right here? You need another boom. Okay, again, you cannot forget the hidden ones. You're probably tired of me saying that, but guess what? We're going to be tired of correcting you on that when we do whiteboards, because you're not focusing on doing the hidden ones. Okay, so 6 to the 1 times 3. Y to the negative 2 times 3. And z to the 7 times 3. Okay, let's simplify. When we simplify, we end up with 6 to the 3rd power. Y to the negative 2 times 3 is negative 6. And z to the 21. Okay. Well, guess what? We're still not done for a few reasons. Okay. First reason is we have a number raised to a power. We can simplify. Second reason, we have a negative exponent. Remember, we're not done when we still have negative exponents. So 6 to the 3rd power will give you 216. Okay. This y to the negative 6, well, it was in the numerator. Okay. Again, if there's not a fraction, we assume we know it's in the numerator. So we got to move that to the denominator. So y to the 6 in the denominator. That's z to the 21. Oops, 21 just stays in the numerator. That is your final answer. Okay. I love exponent rules. It's a challenge and you get frustrated because you make silly mistakes, but it's kind of fun to work with them. Okay. All right. A few more. Let's actually change this to a 2. Let's change that exponent to a 2. Okay. So when we do that, okay, we need to, first of all, not forget that hidden 1. Okay, and everything else has an exponent, so we don't need to put any other hidden ones in there. Distribute, distribute, distribute. Okay, this is so key. Okay, now you don't have to write this down, just watch. Okay, is there a difference? Again, you're not writing this. If I do this, negative 4 to the 1 times negative 2. Okay, or would I do this? Negative 4 to the 1 times negative 2. Which one do I do? Well, do it on your calculator. Do each one. Do the negative 4 in parentheses. Okay. First of all, we should simplify. Again, do not write this. You can just do it on your calculator. So this would be negative 4 raised to the negative 2 power. And then this would be 4 negative 4 raised to the negative 2 power, but no parentheses. Is there a difference? Do it on your calculator. And you're going to find there is absolutely a difference. This one will get you a positive decimal. This one will get you a negative decimal. Okay? We've gone over this a gazillion times. Okay, but with things like this, when you see these parentheses, you need to keep the numbers and everything in parentheses. So our correct work on this, we should show is this. Okay, so let's actually write a key point down here at the bottom. Just do it at the very bottom of the page. Okay, key point is that we must put number in parentheses. Key point. So let's show how it should look. It should look like this. Negative 4 raised to the 1 times negative 2. M raised to the 2 times negative 2. N raised to the 5 times negative 2. Okay? When you do that, you end up with negative 4 raised to the negative 2 power, m raised to the negative 4 power, and n raised to the negative 10 power. Okay? Guess what? All of these are negative powers. And they're all, since there's not a fraction showing, we assume they're all in the numerator. So where do we have to move all of these things in numerator that have a negative exponent? Okay, you should know this, to the denominator. So it would turn into negative 4 squared in the denominator. Okay, and so let's just write it out. Negative 4 squared in the denominator. Okay, last two examples. Okay, first thing you need to do on these, again, you should be doing it. Put in those hidden ones. Okay, and then we need to distribute. When we distribute, we're just multiplying, just like the distributive property. When you do that, you get, keep that 2 in parentheses. Okay, 1 times negative 3, negative 3. A to the 1 times negative 3, negative 3. All over. B to the 5 times negative 3, negative 15. Okay, clearly not done because we have negative exponents. So let's flip them to get rid of the negative exponents. 2 to the negative 3 was in the numerator. Move it down to the denominator, and guess what? That negative becomes a positive. A to the negative 3 was in the numerator. Move it down, becomes positive. B to the negative 15th was in the denominator, so we move it to the numerator. Turns positive. Are we done yet? The answer is no, because we have a number raised to a power. You're not done. It's not simplified. So let's rewrite it. B to the 15th over 2 to the 3rd power. 2 times 2 times 2. Well, 2 times 2 is 4. Times 2 is 8. So 8a to the 3rd power. Final answer. Okay. Last example. First thing we should always look for, negative exponents. Alright, I'm sorry, any hidden exponent to 1. There are no missing exponents, so we don't have to add any exponents to 1, so we can just distribute. Okay. M to the negative 1 times 4, negative 4. 2 to the 0 times 4 is 0. Okay. Well, we can't have negative exponents or 0, so how do you get rid of a negative exponent? Flip it. Okay, it was in the numerator, and again, we know it's in the numerator. We don't have to show it as a fraction over 1, because if it's not a fraction, we know it's just over 1. But if you want to, you can show that. So then you move it to the denominator, m to the 4th. 2 to the 0 power, or anything raised to the 0 power is 1. This would be your final answer. Okay. Now, you guys on these, when you're doing the practice problems, okay, and unless you were assigned, you don't have to do them. Only if you were assigned, you have to do them. But when you're doing any types of practice problems, okay, make sure you're keeping in mind, number one mistake that we were told on this is forgetting to put the exponents in of 1, the hidden ones. And then you forget to distribute to them. Okay? Don't forget that. Okay? Find examples. If you're stuck, Find examples that are similar to the ones that I just went over to help you do the problems. Okay? Use your notes. Really, really push yourselves to not make the silly mistakes. Okay?